Okay, we're going to continue talking about factoring, but this time we're going to be factoring special cases. So the first special case is difference of squares. And this is where we have two terms. We have a perfect square minus a perfect square. So in this case, we have f squared minus L squared. F squared is a perfect square because we can take f times f. If we have a minus right here, we know that one of them is going to be a positive and one's going to be a negative. Because if we were to multiply two positives together, that would be a positive. Two negatives multiplied together is a positive. So we have to have one positive, one negative to get our minus. L squared is a perfect square because we can take L times L. So let's do an example where we can actually see this. We have x squared minus 9. If we were to do what we did yesterday and do the AC method, we would take our a, which is x squared, times our c, which is negative 9. So if we multiply those two together, we have negative 9x squared. And if we do our little t-chart, we want two things multiplied together to get negative 9x squared, and our b would be 0. So they have to add to 0. So we could have negative 3x and positive 3x. Negative 3x times 3x is negative 9x squared. And if we take negative 3x plus 3x, that is 0. So if we write x squared, and we're going to replace our b, which is 0, with these two. So we have minus 3x plus 3x, and then we still have our minus 9. So if we were to group these and find our GCF, our GCF of x squared and negative 3x, we can pull out an x. Our GCF of 3x and negative 9, we can pull out a 3. So if we were to rewrite this, we're going to have our x on the outside. And we're left with, if we pull out an x out of x squared, we're left with x. Minus, if we pull out an x out of 3x, we're left with 3. And then we pull out a positive 3, so we have plus 3 times. If we pull out a 3 out of 3x, we're left with x, minus, if we pull out a 3 out of the 9, we're left with 3. And again, these match, which is what we want. So our answer would be x minus 3 times x plus 3. So we're going to combine those two. So all we did was, if x squared is a perfect square, we know x times x gives you x squared. We know, since this is a minus sign, that one's going to be negative, one's going to be positive. And if 9 is a perfect square, if we take the square root of 9, that gives you 3 and 3. So let's do another example. We have 25x squared minus 49. Alright. So if we look at 25x squared first, if this is a perfect square, we can take the square root of 25, which is 5, and the square root of x squared is x. You can have 5x times 5x is 25x squared. So this is a negative sign. So we know we're going to have one's positive, one's negative. 49 is also a perfect square. The square root of 49 is 7. And you are done. That is your final answer. Next example. We have negative 6x squared plus 600. So, first thing, do we have a GCF? Yes, we do. We can take out a negative 6 out of both of these because we want a positive leading coefficient. So we are also going to take out the negative with the 6. So our GCF would be negative 6. So if we take out a negative 6 and rewrite it, If we take a negative 6 out of negative 6x squared, we're left with x squared minus, if we take negative 6 out of 600, we're left with 100. Alright, so we're going to keep our negative 6 out front. X squared is a perfect square. 100 is a perfect square. So just like up here, we're going to do the same process. So if x squared is a perfect square, what times what gives you x squared? X. Square root of x squared is x. Then this is a minus, so we know we're going to have a positive and a negative. 100 is a perfect square. The square root of 100 is 10. So that is your final answer. And you can always double check your answer by going ahead and doing the FOIL process. One more like these. If we have 81x to the fourth minus 625 y to the fourth. Okay, so the first step, is there a GCF? Well, is there anything that goes into 81 that can go into 625? No, there is not. This one has an x, but this one has a y, so we can't pull out a variable either. So there is none. So our first step, we need to unsquare this. If we unsquare that, what is the square root of 81? That is 9. What is the square root of x to the fourth? That is x squared. So all we did was unsquare. We just unsquared that term. So next we have to unsquare this term. What is the square root of 625? That is 25. And what is the square root of y to the fourth? That is y squared. Alright. So now we can take our 9x squared and 9x squared, because that was the square root of this piece. And it's a minus, so we know we're going to have a plus and a minus. We unsquared this one and got this, so we're going to have 25y squared and 25y squared. Okay, so this piece right here, that is not a difference of squares. We have a plus right here. So this is not a difference of squares. Meaning our answer is going to have this piece right here. So we can just rewrite this. We have 9x squared plus 25y squared. But looking at this piece, oh, looky there. It's another difference of squares. So meaning we have to unsquare each term. If we unsquare 9x squared, the square root of 9 is 3, and the square root of x squared is x. If we unsquare this term, sorry, it's getting a little squished. The square root of 25 is 5, and the square root of y squared is y. So now, if we write this in our answer, just like up top, up here, we're going to have this piece. We're going to have 3x and 3x. This is a minus. So we know we're going to have a plus and a minus. And we unsquared this to get 5y. So we're going to have 5y and 5y. And there's your answer. Alright, if we go down to the bottom, the second special case we're going to look at is the perfect squares. So, looking at this piece right here, we have f squared plus 2fl plus l squared. So, f squared is a perfect square. If we were to take the square root of this, of f squared, we would just get f. Looking at L squared is a perfect square. The square root of L squared is L. Okay, so the difference from the top to the bottom is this piece right there. This piece is just 2 times FL. Where'd we get FL? So all we had was 2 times F times L. So we had 2 times FL, and we got our F and our L. So these, we are going to take, when we unsquare it, we're going to take that term, which is our F, and you are going to keep the sign that's in here. So this is going to be a plus. And then when we unsquare this term, we got L. We're going to keep that L. And the most important piece of this is this square down here. We cannot forget this piece. Alright, so that's when we have a plus right here. Over here, let's look at the one where we have a minus. The only difference is we once again are going to unsquare these two. And this is still 2 times F times L. So if we were to rewrite this, like over here, we're going to keep our F, because we unsquared the F squared. We are going to keep the sign that it has. So this is going to be a minus. And if we were to unsquare this term, we got L. We're going to keep that L. So same thing, except this was a plus, this was a minus, and that sign carries into our answer. And don't forget your squared. So if we have an example, we have 4x squared minus 28x plus 49. So first thing, is there a GCF? Is there something that goes into all three of these? No, there is not. So there is no GCF. So we are going to unsquare this term. So if we take the square root of 4, we get 2. If we take the square root of x squared, we get x. 2x times 2x is 4x squared. Alright, notice our sign is a minus. So we know that we are going to have a minus in our answer. This piece, we are going to unsquare this one. What is the square root of 49? Well, that is 7. So this piece right here, the 28x, was just 2 times this piece, which is 2x, times this piece, which is your 7. If you take 2 times 2x, you'd get 4x, times 7 would be 28x. So this middle piece is just 2 times your piece that you unsquared, times this piece that you unsquared. So if we were to write this, your answer, we would get this piece, which is what we did to unsquare this. So you're going to have this term, which is 2x. You're going to have the same sign as the problem had, so we're going to have a minus. This term, 7. And we cannot forget our squared. And that is your answer. Okay, let's do one more example. we have 2a squared minus 16a plus 32. So first thing, check for a GCF. Do we have something that goes into all three of these terms? Well, these two have an a, but this one doesn't, so we can't take out a variable. But 2 goes into all of these, so our GCF would be 2. So if we have a GCF, we're going to rewrite it with our GCF out front. So we're going to take our 2 out front. If we take a 2 out of 2a squared, we're left with a squared. If we take a 2 out of negative 16a, we're left with negative aa. And if we take a 2 out of 32, we're left with plus 16. Okay, notice our sign is a subtraction sign, so we are going to have a subtraction sign in our answer. So, unsquare this term. If we unsquare it, we take the square root of a squared, which is just a. This term right here, 16, if we take the square root of 16, we'd get 4. So all we did was unsquare 16. And our middle piece is 2 times this term, which is a, times this term, which is 4. 2 times a is 2a, times 4 is 8a. So now we can write our answer. We still have our 2 out front, so we have 2 times, we have our a, and we keep our sign the same, so we have minus this term, which is 4, and we square it. And there is your answer.